So in 2C, we have figured out that the moment generating function of S is equal to some value for certain alphas satisfying a condition, and it's equal to infinity otherwise. The interesting thing here is now whether this moment generating function even corresponds to some distribution. There is a theorem somewhere out there in the world that says there is a one-to-one correspondence between a moment generating function and a distribution if the moment generating function is finite on a neighborhood of 0. So just to make sure where this moment generating function is well defined, let us take a look at which alphas that allow for this term to be equal to be smaller than 1. And if there are some alphas in the neighborhood of 0 that allow for this, then we're safe. So let us consider which alphas let the numerical value of lambda divided by c theta minus c alpha be smaller than 1. Now first, recall that the net profit condition yields that the expected premiums must exceed the expected losses. And therefore, we have that lambda divided by theta c is smaller than 1. Okay, now we have that. What we want to look at now is how this thing looks for different alphas. First of all, you can note that for alpha smaller than equal to 0, what you get is you're taking lambda divided by c theta, and instead of dividing by c theta, you're actually dividing by something larger because c alpha is negative. And therefore, this fraction is smaller than or equal to lambda divided by c theta, which in turn is smaller than 1. What happens then when alpha becomes strictly greater than 0? Well, then we need to be careful, because you see that as soon as alpha hits theta, this fraction actually turns into infinity. So somewhere between alpha being equal to 0 and being theta, this fraction starts blowing up. Because what you do is you subtract by something that's positive. So you divide by something that is first c theta and becomes smaller and smaller and smaller and decreases towards 0, right? So we need to be really careful here. However, we can note that for alpha greater than 0, there is a case where since lambda divided by c theta is strictly smaller than 1, well, then there exists some epsilon between 0 and theta, some epsilon which is sufficiently small such that lambda divided by c theta minus c epsilon will be smaller than 1. And since that is the case, we know at least that this fraction is smaller than 1 for all alpha lying in the interval minus infinity to epsilon. And we now have a neighborhood around 0 on which the moment generating function is finite. And that is nice. Now also note that as soon as alpha exceeds 2 theta, then this fraction again becomes smaller than 1. But that's not what is relevant for us here. The relevant thing for us is that the moment generating function is indeed finite on some neighborhood of 0. In the next video, we will do D, where we will continue calculating this moment generating function, try to get a nicer expression for it, and then we will recognize a mixture distribution.